To Forces 2 Lesson 6, and we're going to be talking about what are the 7 forms of energy. And so you might have some ideas as to what types of energy there are. You might have natural gas in your home. You might also run around all over the place. All those things are examples of energy. I need energy to do this video. I need some electrical energy, electromagnetic in particular, to get this iPad and to get my computer to work. I also need energy to move around, so I have to eat food, I gotta sleep, and all those different things too. You also need energy to power your home, and so those are all different types of energy. And so this lesson we're going to be talking about what the different types of energy are today. And so we're going to go over some of those today. Basically, when I talk about energy, basically it's the ability to do work. And so energy is usually measured in joules. We talk about it, and as you can see here, it is spelled with a Joules, and we use a J there. And work is basically if something moves and it requires energy, then you've done work. If it doesn't move, technically it didn't really do any work. So that's something that you'll learn a little bit more in simple machines in later years in the STEM program that we do in 8th grade. But energy, simply put, is the ability to do work. And there are several different types of energy that we have for that. Okay, and I want you to think about, well, what are some ways that you have used energy today? I want you to think about that, and then you're going to go into completing the rest of this section of your notes. Okay, first one is mechanical. This type of energy is when an object is in motion due to its position. This is a little bit different from kinetic, where it's just in motion, but this one requires something to move it. It's just the form of energy, whereas kinetic is a type of energy. So there's a little bit of a difference there, but you need to know that, like for example, with this object here, the hammer that you have, it is mechanical because it requires the lever of your hand to smash it, to put the hammer down. If you get this picture here with the guy doing the bench press, he needs to have his arms over there, and he needs to push up in order to get that moving. The car has pistons in it that rotate back and forth, and it uses the simple machines in there to do that. So it requires the use of mechanical motion, which has levers, pulleys, and all those simple machines that we use. And so those are all examples of mechanical motion. So you need to have some examples down there. Now, kinetic. Kinetic is the wide umbrella of energy in motion. If it moves, it has kinetic energy. So like a Jaguar does have kinetic energy because it's moving. This rocket is moving. It has kinetic energy. These are moving. This is moving. However, the way in which it moves is mechanical energy. And so there's a little bit of a difference there. So make sure that you know that and come back to this if you need to. Next, there is potential. And so with that, I lost it. There we go. Potential energy is stored energy due to its shape or position. We also call that gravitational potential energy, which means that it requires not just the stored energy inside of it, like you would see when you stretch a rubber band, or when you push down a spring, or when you pull back an arrow, but also its height due to gravity can also cause that. Like the top of a roller coaster has gravitational energy. The higher a ball goes up in its throw, the farther down, and the more it'll accelerate on the way down. And so that's why we use not just potential, but gravitational potential energy. And so that's potential energy there. Another one is chemical. If you ate breakfast this morning, if your house uses fossil fuels, or if you just, got to school this morning, it was because of chemical energy. And that's, energy stored in the chemical bonds. Whenever you break chemical bonds, you see a pop, a fizz, a burn, a color change, heating up, cooling down, all those different things, you will see energy released. And so as a result, whenever we eat, the digestive system breaks it down into all those different chemicals that we have and what we need, but that breaking down of it gives us the energy. So we need our carrots, we need our fish, we need all those different foods that we have Photosynthesis, energy drinks, they have all that weird stuff in there that focuses on energy type stuff. Fossil fuels is carbon broken down and fossilized. So this is actually, it could be like a tree or plant material that millions of years ago was pressed down and fossilized. Could have been found in a tar pit, and then it dried, and then it compressed and turned into a rock. And so we can burn that and release the energy from it. Anytime there is fire, it's chemical. And anytime, in a car engine, that uses chemical energy because we're burning gasoline to make those explosions within the pistons there, and that causes them to rotate and move. So that helps with the mechanical energy too. So that idea of conversion of energy also comes into place. Now we're on to electromagnetic energy. And this is a huge, huge umbrella. In fact, it's energy due to electrical charges and waves. In fact, this encompasses radio waves, microwaves, infrared, visible light, UV, X-ray, gamma, and we use a very small portion of this. What we actually see is about 10% of what is actually out there. And so all these different things here, we only see this small gambit of UV or of electromagnetic waves. Like X-rays we use at the doctor's office that we need to make sure that our arms are broken or not, and anything inside of our stomachs and in our bones and all that stuff. We use X-rays. It gets into our skin and through there, and so that's why they have us wear lead, because that penetrates, that goes against, or that keeps this from penetrating our skin. And too much X-ray radiation can cause possibly some cancers. Gamma rays, those are, different type of frequency that we have there. UV, it's going to be sunny out this next couple of days. You need to wear your sunscreen. That's ultraviolet rays. Those are the sun's rays that go through the atmosphere and into your skin, and it can cause that tanning, but can also cause the changing of skin cells in order to make those nice little beauty marks that we like to call moles, but also can cause premature aging and cancer over time, skin cancers. Infrared is heat moving in waves. Microwaves, whenever you zap your food, you're putting energy into it, and that's causing it to sizzle. And then radio waves, whatever you hear, you don't see radio waves, but they are going all over the place, so that you can hear on the radio, but you can also hear many other frequencies that are going on. So this also includes just electric, the movement there, and magnets and how they move energy as well. So that's a huge one. You should be able to find a ton of examples there. And then one of the easiest ones we know of is heat. So whenever energy changes due to temperature, and this is caused by movement of particles. So, as energy changes, phases of matter. So when things heat up, like ice to a liquid, liquid to a gas, this changes the particles. Whenever we jog, we're giving off heat energy because chemical energy is being released. The friction of our muscles and the work that's being involved there, it makes us sweat and heat up. Okay, so it changes that. Fire gives off heat energy as well as chemical, and light energy, which is electromagnetic. And then cars, they overheat. The sun gives off heat energy as well as burners and stuff. So we got those two. And so our last one that we're going to have is nuclear, the splitting of atoms. This is the one that people are like, ooh, but it's one of the most dangerous, but also it's very on topic for today as far as a hot topic here. The sun gives off nuclear energy. That's what keeps its energy going. It's splitting atoms inside its core and within it and throughout. And so as a result, it's giving off huge amounts of energy that come to us and give us the energy that we all use. Not even if we're inside, we see the light, we feel the heat of it. Otherwise, if the sun was not there and not giving out its energy from many millions of miles away, we would not exist. Okay, so thank you, nuclear energy. Good job. Okay, so we have all this energy here, all these different types. Also, we have very locally TMI, the nuclear energy from there. And so these are the different types of energy. Your task in class is to be able to identify what type of energy it is based on the context. So I see someone eating food. That's kinetic because his mouth is moving, or it can be mechanical because it requires the muscles to move in order to do that, or it can be chemical because he's eating. So those are the types of things I want you to be thinking about and being able to identify those things given the context. So you're going to finish these notes all the way to the law of conservation of energy. Do not do that. That'll be the next video. Okay, so those are the 7 forms of energy. With that, you should have your notes finished with all the examples and ready to do some examples and identifying different types of energy.